So now let's look at our other last effect, that is like fish in water appears bigger or magnified, okay? That if you look at fish in the water, it will look too big, okay? What is the reason? If I can make some drawing like that, if this is my fish, okay, what happened is light rays from here, because it is moving here, it will be refracted, it will be refracted in someone's eye here, and now in that person's eye, the refraction will not be noticed, okay? Or the bending may not be noticed, but it will still look like it is coming from here, okay? And then at the end, when you're seeing a fish, you'll see something like this. So this is the image, or the magnified one. Why? Why does that actually happen? If this is water. Why does that actually happen? So we are saying that this is because the surface of water, however much you may look at it and you think it is flat, the surface of water, if you go at the lake, it is not really purely flat. It has some kind of ripples as a result of maybe say waves and so on. There are countless ripples in that in contact with the air, these ripples looks like a convex lens. A convex lens is like this. Okay? So this surface here looks like a convex lens. That is what happened. And again, we know that with the convex lenses, if the image is, if the object is within the focal length, the image is always magnified. We are going to look at that. I'm repeating it. For convex lenses, if the image is within the focal length or before the focal point, the image is magnified. And that is what we are calling a magnifying glass. Okay? That for magnifying glass, we ensure that the object is within the focal length. If the object is within the focal length, the image becomes big. So that is the action of a magnifying glass. So what happens is the surface of water, which is like ripples like this, there is a surface in contact with the air that looks curved like a convex lens. And even is curving, it is having radius of curvature. And therefore, it is also having a focal length. And we have said that if for any lens or for any curving, if the object is within the focal length, what happens is it will look magnified. So that means that this fish also, if it is within the focal length of this, it will look magnified. We shall look at what we are talking about, the image being magnified for convex lens. So what can we write about this? We can say the surface of large water bodies are not completely flat, but instead consist of a countless ripples, of which the surface in contact with this consists of countless ripple in which the surface in contact with the air is like a convex, is like a convex lens of long focal lengths. The ripples, there is a surface that is in contact with the air, it forms a ripple. The ripple is like a convex curving, a ripples. I can say there in the bracket a convex curving. A ripple which surface in contact with the air. Let me just put it here. Convex curving. Convex curving. The ripples in bright convex curving of which the surface in contact with the air behaves like a convex lens of long focal lengths. Okay? The surface which is in air, the curving with the surface in air behaves like a convex lens but long focal lengths. So we say an object within the focal lengths will therefore appear magnified, and hence if the fish is also within the focal lengths also appears if the fish is also within the focal lengths will also appear magnified, in bracket appear bigger. Okay, so that is what we can talk about why a fish looks bigger. So it is all about knowing that for any convex curving, for any convex curving there is a focal length, okay? Or any curving has a radius of curvature, and with the radius of curvature there is focal length. So, and if we have an object within the focal length of any lens, convex lens, it will always appear magnified. So if the fish is also located within the focal length of this curving here, therefore it will appear magnified. So that is also as a result of refraction. The light rays from here will come into this, will move from more dense to less dense, and therefore will be refracted in this guy's eye. As is refracted here, this guy will not see the bending on the refraction. For him, we will see as if light has traveled on the straight line. Instead, we will see this fish here as magnified. And that is the explanation we can give about a fish in water appearing bigger.